what is the ripple effect from my perspective? And my perspective will be from science. So let me start by mentioning how this happened to me and how I got so excited about science early on in my career. In 1957, Sputnik was launched, and I was 6 years old. I didn't understand exactly what was going on, but the excitement was obvious. Everyone was talking about it. People would go out at night trying to see it. I never had an opportunity to see it as it flew overhead. But by 1958, NASA came into being. This was also an incredible opportunity to build organizations that really would explore not only the Earth environment, but go perhaps further in space. So what did we know at that time? I can tell you we knew the Earth's magnetic field existed here on Earth, but we did not know how it extended into space. I can tell you we thought about what was happening at the sun like the solar wind. The sun constantly outgasses in all directions, but we really didn't understand its effect. We also had aurora, things that were particles that were raining down on our upper atmosphere, but we didn't even know where they came from. And there was so much in terms of what we couldn't see because the electromagnetic spectrum that we do see on Earth is so very limited. The sun looks like an ordinary star. You can look at it, has a couple spots on it. We wouldn't, from that perspective, call it a variable star. But what happened next in the space age, of course, was in 1959, James Van Allen launched an experiment that discovered the Van Allen radiation belts, the first major set of scientifically challenging high-energy particles that are caught in our magnetic field. We only theorized that, but Dr. Van Allen was able to really pioneer and understand that. By Explorer 4, he discovered another set of belts. We call them the outer Van Allen radiation belts. I did not know that at the time, but when I went to the University of Iowa in 1969, James Van Allen would be my friend, my mentor, my teacher. And this inspired me to get very much into science, to solve the questions about what was space like and how we were going to live and survive in this world, in this new environment that we were uncovering. Well, let me fast forward to today. By 2015, New Horizons passed by Pluto. That means we have completed the initial survey of the solar system. NASA, and many of the other space agencies, through the exploration of space, now has pioneered a number of new scientific fields. If you were an astronomer and you looked at planets prior to the space program, you did it with a telescope. And now we visit them. We fly by them, we orbit, we land, we rove, and we return samples, and we created a brand new discipline called planetary science. We also have the opportunity to look at these planets and understand their geological history and begin to thinking of what were they like in the past. And we've uncovered that Venus was a blue planet, that it's only been within the last 800 years that Venus has turned into a runaway greenhouse with an enormously hot atmosphere, no water on the surface anymore. And so perhaps Venus was our first habitable planet in our solar system. Mars, we have discovered, was also a blue planet in its past. But it lost its oceans early on, perhaps 3 billion years ago, because it lost its magnetic field and the sun scoured the atmosphere, and it lost a lot of the oxygen after it was disassociated with the hydrogen, never to return to the planet's surface and create the water that is so necessary. These are now the things that we know. This is the backdrop of the science we're going to investigate. And so what is the ripple effect of the science that has been uncovered by the space program today that should inspire our students. It is clear, as a planetary scientist, that the climate on this planet has done nothing but change. But it's also clear the rate of change is so much faster because of a number of inducements that are occurring because of the life on this planet. What's happened in the past is life was able to evolve through those changes because of the long time scales. What took perhaps several thousand years is taking less than 100 years for the climate to change. So the new students coming through are inheriting a world that they must know more about. We need more scientists. Another thing that we're finding out is we're actually in a horrible orbit. Yeah, we orbit the sun, and there are things that hit this planet. We now know there's more than 60,000 near-Earth objects. There's about 1,000 of them that are planet killers. There's more than 2,500 of them that cross our orbit that will hit this planet. It's not a matter of if, it's only a matter of when. That is really important to know if this species of ours is going to survive. This new generation of scientists now have to solve some of those problems in the future. We need more scientists. We also have uncovered some new, really important cycles that the sun goes through. We know the sun goes through a sunspot cycle every 11 years, but we didn't imagine what could happen on occasion when the sun can become really angry. It is a variable star from that perspective. Huge superstorms can occur on the sun on timescales of several hundred years that can hit our planet and create enormous problems because the currents in the atmosphere that try to respond to those coronal mass ejections that rip open our magnetic field, that precipitate the Van Allen radiation belts, that cause auroras to move through Canada, through the United States, through Mexico, through Central America, and if you were in Colombia, you could look up and see an aurora. Those currents knock out our power. They induce currents that take out our power grids. We'll come to a time, if one of these geomagnetic storms that hit us, that will change us from the technology societies that we have today to going back in time where many, if not most people on this earth will have to chop wood and shoot squirrels out the back door for them to be able to survive. We now know that that can happen. We've seen it in the history of this earth, that these geomagnetic storms are occurring. We now, because of our technologies, must take that into account for us to be able to survive. And we're handing that over to the next generation scientist. And we need more space scientists. And then, of course, finally, in the longer area, we're also seeing that as the solar system moves through the galaxies, in a couple thousand years, we'll be moving through a major interstellar cloud. This will shrink, perhaps radically, our heliosphere, which will also end up bringing far more cosmic rays into this environment. Right now, our heliosphere is preventing about 75% of the cosmic rays roaming the galaxy to get to us. But that will all change in a couple thousand years as we move through these galactic clouds. The bottom line is this: we need our next generation to tackle some of these tough problems and begin the process for us to be able to survive in the long run. This is an exciting time. I wish I just graduated from the University of Iowa to be able to be part of tackling these. We have a great engineering course. We've talked about this all the time. We have fabulous things going on where we're learning things on the International Space Station that will affect our life down here on Earth, including human research that's being done in new and unique ways. but we need more scientists, and we have to be able to work hard to educate them. There are right now about 70 countries involved in the space activity. I mean, it's not just the United States and the former Soviet Union racing to the moon. We are joining forces in the Artemis Accords to go together into space. This is a wonderful opportunity that instills peace and the peaceful uses of space as we begin to cooperate with multicultural activities such as our astronaut panels really delineated. It's a perfect time to be able to bring up that next generation. The ripple effect of what we know about space will change the way we live in the future. It's really in their hands, and we must help them by educating them in any way possible we can. Thank you very much.